All right, so that's our last lesson, and that's about solving word problems. So, what were the exponential equations that we talked about yesterday? The exponential equations that we talked about.
The
Y equals to bx.
Sorry.
Y equal to
AB to the power of x, right? But we talked about also the difference between the b's, right? We talked about that b is greater than 1.
It's growth.
Growth. If it's b between 0 and 1,
Decay.
it's decay, right? And we talked about that when we are given weights, right? What we have to do, we have to kind of change that b into y equals a 1 minus I, right? And then y equals a 1 plus I for growth. Okay? This is when we are given rates, like percentage. Okay, so like 2%, 3%, 4%, right? We have to do that. Okay? But if we know what our factor is, growth factor or decay factor is, then we can plug it into B right away, right? When we did the table of values, for example. Do you remember? So let's look at these examples right here and let's try to see what's going on. So a principal of $500 is invested at 8% per year, compounded annually. Write an exponential equation to represent the relationship. Compound means, we're going to do that next in MAP 4C, but compound means it's you getting interest on the interest. So let's say you put the $500, right? And then for the first year you got, whatever, $20 interest. So now you have $520 in your bank account, okay? For the next year, you're going to get interest on the 520, not only on the 500, right? So we have two types of interest. We have the simple interest, which you just earn the same interest every year, no matter how much money you have in the account. It's always on what you invested originally. Or we have the compound interest, which is after the first, and it's compounded differently. Right? So in this case, it's compounded annually. Sometimes it's compounded monthly, semi-annually, bi-weekly. You know, the bigger if it's compounded, let's say daily, that's the most, right? Where you're actually earning interest every day on the new number. Okay, it is.
People do
but
this?
when
That's true.
you know when they do that, if they're borrowing you money. If they're lending you money, then they will do it because then you have to pay them back a lot more. Right? So they'll say like compound, like you have to pay me interest compounded bi-weekly, right? So that means every 2 weeks your interest is kind of like accumulating, right? So if you look at your Visa statement or at your MasterCard statement, they say like if it's not paid by this due date, then you have to do compounded whatever. Certain percentage, 21% compounded monthly. Right? Yeah. It's great. So, in this case, it's compounded annually. In this course, I don't think we do anything other than compounded annually. That's the easiest we can read. Okay? So, we know that we're investing $500. That's what we're starting with. Okay? And then we know that we have to, we are getting 8% per year, right? Is it a growth or is it a decay? It's a growth, right? You're getting the money, you're adding money. So what formula do I have to use? So let's use just the generalized one.
Y, A, bracket, I, 1. Oh, 1.
Plus
I, N.
power x.
And x, whatever. That's right. Okay, so it's a growth. So it's 1 plus I. Okay? Now, what's the initial amount?
500.
500, right? So my initial amount here, which is the A value, is y equals 500. I'm just showing you steps here, but when you're doing these examples, you don't have to do these steps. Okay? So submit the common ratio. Now the common ratio in this case, I have to use 1 plus I, right? If the common ratio is given to you, we have to use the formula y equals a b to the power of x or n, right? So the common ratio, which is, in this case it's 1 plus I, but in other cases it's just b, okay? So for special cases or special words like double, what do we use for b? Double. 2. For half-life, what do you use? Half, 0.5. For triple, what do you use? 3. Okay? So in this case, you go back to this formula, right? You don't have to do the 1 plus I. But in the cases where we have a percent, right, which is the case that I have to convert the percent to a decimal. And then for growth, I use 1 plus I. And for decay, I use 1 minus I. Okay? So in this case, because it's a growth, I've already figured it's 1 plus I. Okay? So, what's my I?
0.08.
0.08. Okay, make sure you use your calculator so you don't do mistakes with decimals. And what's my N?
2 year, 1.
How many years?
1 every year.
Okay, I'm going to leave it as N for now because it doesn't specify for how many years. If it tells you what would your amount be, how much money would you have in your account after 10 years? You just plug in 10 for.
You don't have to do it because it says compounded annually.
Yes, compounded annually, that's going to be the case for every year.
Yeah.
So every year you're going to earn an interest, but you don't know how many years you put it in.
Oh, okay, here we say.
Right?
So what about if the back is, for 10 years?
If it would be 10, the end would just be 10.
10.
If it was,
No,
but it
it's
doesn't specify.
in future it's a 10 years, right? Like for 10 years, so it's go 10.
Instead
So
of
if I go in past, like
You can't do
after,
it fast. There's no like.
how much money in last 10 years?
But I'm starting with $500 now. I had nothing in my bank. Right? But if there's a case where they're asking you for previous years, let's say like today or whatever population, then you have to put a negative number. So let's say what would the population be 5 years ago, right? You put -5. Okay? Because that's only in the case of population or things like this or bacteria growth or whatever. But in the case of money, you can't do it because you're studying principal right now, right? So you have nothing in the account. But we'll talk about this in the next question. Yes?
Evidence between 0 and 1, we are putting negative. Why that's like 0.08, right?
Yes.
Or it's plus that.
Because the amount is growing, right? To make it a growth, you add 1. So it's 1 plus the 0.08. Okay? So technically, y equals 500, 1.08 to the power of n. Now your base is 1.08, which is greater than 1. Right? Are you guys okay with this? Sorry?
You're alright as a teacher.
Am I? What? Sorry.
You're not bad as a teacher, you're a good teacher. Okay?
Oh, thank you.
I was thinking that the whole time.
You had to say it, didn't you? Okay, so a new car costs $20,000. Its value decreases 16% per year after it is purchased. Write an exponential equation to represent the relationship.
Let's see y equal to a 1 minus I power of n.
That's right. And y is a minus. What tells you it's a minus?
Decreases.
Decreases. So you have to look for these like, keywords, right? So y equals a 1 minus I to the power of n. Again, because it's percentage, we have to use these formulas.
That's still clear? That question is done? Finished?
Yeah, this one is right here is done. They just want you to write the equation. They don't specify how many years or anything. So what's my A value here? What's my initial value? 20,000. So this is how much you bought the car. What's my I?
My I.
0.60.
0 point.
Your I.
My I.
What's your eye? Your eye. Your Oscar eye.
Okay, guys, as I said earlier, please make sure that you use your calculator to calculate this if you are not sure how to get it right away. So do 16 divided by 100 on calculator, so you're not messing up with a decimal. Okay? Because that makes a big difference when it comes to calculating money or whatever it is, right? Okay, so I can end my equation should look like y equals 20,000. What is that? 0.84 to the power of, right? And is it decreasing? Yes, it is, because my base is between 0 and 1.
Yep.
Okay? So always ask yourself, does my answer make sense? Are we okay with this? Oh.
So, we have to finish it all, like y is equal to, then after that we multiply it, or?
No, you don't multiply because you can't multiply unless you know what n is. Because remember BEDMAS? That's a very good question. Tim? Eric, I want you to listen to this. You can't multiply 20,000 by 0.84 because BEDMAS says you have to do your exponent first. So you have to do this first, 0.84 to the power of n,
And then?
I don't know what n is, times 20,000. That's why I have to leave it as is. Okay? And a lot of mistakes happen because people don't use BEDMAS properly.
Can you just put a 1 in? Like, because it says per year. So can you just put a 1 in for n?
And the question is asking you to write,
It's just like annually.
if you go back here, determine an equation of exponential relationship, rate of growth, or decay. So they just want you to determine the equation. They don't want you to find the answer. There is no number of years. It's not telling you what is the price of your car after 1 year. There's no question. Okay. So the population of Alberta between 1987 and 2005 can be modeled by an exponential equation. The population in 1987 was 2.4 million, and the growth rate was 1.7%. Write an equation to model the situation.
So it's going to be one of the growth or indicating
Okay. Y equal
percentage
to.
change, right?
It has to be, yes, it has to be the one,
Growth or decay because.
growth or decay. Which one is it? Growth or decay?
No, it's growth.
It's growth because
It says.
it says growth rate.
Yeah.
Yes,
So A is gonna be 2.4 million.
that's right. So A is going to be 2.4 million, but I have to specify that this is since 1984.
Yeah.
So when I write this, I have to specify that this equation is since 1987, sorry. And 1987 means that's my year 0, right? So when I come to plug in numbers in for my number of years, I don't plug in 1987.
You go
I plug in 0 for that.
2005.
What would be for 1988? 1. 1989, 2. 2000, sorry, 1989, so that's 1990.
1999.
Right?
Yes,
So that's
skip a
3.
year.
You know what I mean?
Yeah.
So that's why I have to specify that since 1987. Okay? So let's write that down. So y equals,
Yes, 7 is old.
you can write y, you can write p, whatever.
Anybody
2.4
equals
million. So
1.7.
2.4 million is
I know.
240,
That was
0,
90.
1, 2. and then 1 plus
Plus 0.01
to the power of n, where n is the number
She skipped you.
of years since 1987. You guys have to write all of this.
He's still good over here.
25.
No, 1992.
Number of years.
So you are quarter century.
Yeah, man. Feel it too.
Yeah, feel it too. Does it feel hurt?
You feel old. It's old.
How can you find the 2.4 million as a number? Like as a not only 2.4 and writing million. How can you, like if you don't know it, how can you use your calculator?
Times thousand?
Times million.
Times
A million has 6 zeros, right? So you can do 2.4 times
A million.
a million. It would give you the actual number how you do write it. Cool.
I always know that just like if it's 1 million, you put 6 zeros. And if it's 2
Yeah.
million, you put 5 zeros. Like, sorry, if it's
6
like
zeros
1
as well.
million.
Yeah, 120,000. So if you wanna if you wanna find 2.4 million, just multiply 2.4 by a million, which is 1 and 6 zeros.
Yeah.
So use your model to calculate the population in 1985. 1985, what does that mean?
So, 2 years, we lost, oh, this is decay. That's crazy.
No,
Yeah, it's just the power of n
It's just the growth.
that's right. So that's 2 years ago,
Yeah.
right? If your 1987 was year 0,
-2.
so 1985 is -2, because that's 2 years ago, right? So what I do, I plug in -2 in for n, so what is the answer for that? 232.0435. If you get a decimal for population, please change it. We will not have 0.1 of a person, right? So change it.
What if they're a little person?
Still counts as a person.
That's a 0.1 number.
Okay, now the next question say use your model to calculate the population in 2012. So how can you find how many years do you have between 2012 and 1987?
Just subtract.
Subtract. So if you subtract 2012 minus 1987, you get 25.
Minus 25.
Right?
Yeah.
So that means your n is 25. You plug it in.
You go on.
You should be getting bigger number than 2.4 million.